Today we're just going to solve some problems using Snell's law. Light strikes in air and water boundary with an angle of incidence of 30 degrees. What is the angle of refraction of the reflected ray in water? So we have air here and we have water here, and the index of refraction of water is 1.33. So what we're going to do is calculate theta 2, which is going to be the angle of refraction. So we have the index of refraction of n sub 1, that's going to be 1, sine 30 is equals to 1.33, the index of refraction of water, and sine theta 2. So in order to calculate theta 2, we can just manipulate this equation a little, and we're going to take its arc sine, and we get theta 2. So now using our calculator, the angle of refraction of this reflected light ray in water is going to be 22.1 degrees. A light ray travels from air into glass with an angle of incidence of 60 degrees. The light ray continues to travel through the glass material into diamond. At what angle does the light ray make the material line as it enters the diamond material? So you can pause the video and try this problem. So this one is tougher. We're going to calculate theta 3, which is the refracted angle that is created of the light ray that travels from glass to diamond. So now let's try to calculate this. So we can just use this equation, this Snell's law, but we're going to add more variable. We're going to add n sub 3 and sine theta 3 because they are just equal. So this light ray is the same for all mediums. So first what we're going to do is calculate theta 2, which is the refracted ray angle of air to glass. So let's substitute what we know. So the index of refraction of glass is 1.5 times sine theta 2. So theta 2 is equals to arc sine of sine 60 divided by 1.5. So we can just quickly use our calculator now. So theta 2 is going to be 35.1 degrees. So that's the index of angle of refraction of air to glass. So now let's calculate theta 3. So now let's plug in what we know here. So the index of refraction of the glass is 1.5. We have sine and we calculated theta 2, which is going to be 35.1. And that is equals to the index of refraction of diamond, that's going to be 2.4, which is the highest index of refraction of all substance. So it's okay. Now let's calculate theta 3 by using our calculator here. We just manipulated some of equation here. Okay, let's delete this. Okay, so theta 3, which is the index of angle of refracted ray from glass to diamond, is going to be 21.1 degrees. So this is the answer. It's 21.1, not 25. A light ray strikes a material with index of refraction of n equals to 1.2 from air to an incident angle of 70 degrees. What is the angle x in which the light ray leaves the material? So we have a specific angle that we are going to calculate here, which is we call it x. So there's a light ray that hits this material, and its incident angle is going to be 70 degrees. So first, we're going to calculate theta 2, which is the index of angle of refracted ray. So to do that, we're going to use Snell's law once again. So n1 here. So now we're going to plug in what we know. So n sub 1, this is still in the medium from air. We have sine 70 degrees. And let's just make this easy. We'll know the formula. And let's divide this by the index of refraction of the material, which is 1.2. So theta 2, which is the angle of refracted, is raised, so it's going to be 51.5. So it bends a little because the index of refraction is a little bit higher. So now we can just use some concept of triangle here. So we have a theta 2 here. As we can see in the illustration, we form a right triangle. So we have theta 3 here. That's what we need to calculate and use Snell's law once again to calculate the value of x. So we have 51.542 in this angle, and we all know that this is going to be right triangle. So the sum of the angles of the triangle is going to be 180 degrees. So we got 51.5432 plus 90 degrees plus theta 3 is equals to 180. Now we're going to move the two values to the right side, so that's going to be negative. So 180 minus 90 minus 51.5432. So theta 3 is going to be, what do we got here? 38. 30, 38. Sorry for that. That's going to be 38.4. Okay, let's make this. So now let's calculate the value of x by using Snell's law once again. So let's delete all of this thing. Now putting our equation once again, we have theta 3 is times sine theta 3 equals to n. Oh no, did write this. This should be n sub 3. Why do I keep writing it that way? So we have sine theta 4 here. So now we're going to calculate theta 4, which is going to be the value of x, and that's the solution for our problem. So theta 4 is equals to arc sine of 1.5 times sine 38.4. I just deleted the value earlier, but I still remember this. And it's going to be divided by 1, which is the air. So now theta 4, which is the value of x, is equal to, let's change this. This should be 1.2. So that's going to be around 48.2762. So it bends, does it bends away? Yeah. It bends